You are live on Dr. OJ Digital's online tutorial this afternoon. So if you are there, I want to hear from you by sending yes, because we are going to start in earnest. This is a live program, a live tutorial class for students in 100 level who are doing MTS 101. In this live tutorial class, we are going to discuss and review a lot of the aspects that have been taught in the MTS 101. So if you're online, please indicate by saying good afternoon, sir. If you're live with Dr. OJ Digitalz, say hi, good afternoon. Good afternoon, good afternoon, good afternoon. Can you hear me clearly? Can you hear me clearly? Say yes. If you can hear me clearly, say yes. If you can hear me clearly, say yes. Good afternoon. Can you hear me? Oh, okay. So in this live video, our focus shall be on 4 major topics. And this topic shall be polynomials, AP and GP, matrices, and sets. I repeat, polynomials, AP and GP, matrices, and sets. So I hope you are all ready and get ready for this explosive tutorial class that we're going to have this afternoon. If you are not in this tutorial class, you are not anywhere, because a lot will be discussed. Thank you. So without wasting our time, like I've said, the contents outline or what we are going to discuss will be based on what? 4 main topics. These are the polynomial, AP and GP, matrices, and sets. Now let's start with the polynomial. Let us start with the polynomial. We are going to solve some polynomial questions to actually review what we have learned so far in polynomials. So we are going to solve what? Some polynomial questions to review what we have studied so far. Now, let's start with what we call factors of polynomial. Factor of a polynomial. Factor of a polynomial. What do we mean by factor of a polynomial? Now, an expression is said to be a factor of a polynomial if the root of that expression will give 0 in a polynomial. For example, if f of x is a given polynomial, now this f of x could be what? Let me take a quadratic expression as an example. Let's say ax squared plus bx plus c. This is a general quadratic expression. Now, this f of x, we have the roots of this particular expression will be what? If we use factorial formula method, we say x is equal to plus or minus square root b squared minus 4ac all over what? 2a. Now, in this case, plus or minus a means x will be plus the whole of this all over 2a, or x will be minus the whole of this all over 2a. So 2 roots will be given there. 2 roots will be obtained. So now, this function f of x, this polynomial expression f of x, will have a root as what? As this. These are the 2 roots, because it's a polynomial expression, it's a quadratic expression. It has 2 roots because the highest degree of x here is 2. Now, what is now the factor of this polynomial? The factor of this polynomial is x is equal to plus this over this, or x is equal to minus all of this over this. So we can have, if I put x is equal to this into this expression, I will get 0. If I put x is equal to minus the whole of this into this expression, I will get 0. So x, let's say for example now, suppose if we have x, if x minus a is equal to 0, okay, I choose this as what? As like, let's say this is our divisor. Now x will tend to what? A. So this polynomial expression f of x will be f of a will be equal to 0. So in that case, you say x is equals to a is what? Is the roots that give us 0, which invariably means x minus a is the divisor. Now, I will buttress this explanation with a very clear-cut example. Don't worry, you will understand what I'm trying to explain. This is just a what? A prelude to what I want to do here. Now, let us go to a very, very illustrative example. Suppose we are asked to factorize. Let's say factorize what? S cubed minus x squared plus 4x minus 4. Suppose we want to factorize that expression. Now, I want to factorize that expression. Now, what does this mean? We are only asked to find the factors of this expression. Now, there's something we call trial and error method. Trial and error method. What do we mean by trial and error method? Fine. We use trial and error method to know the possible factor of this polynomial. Now, what do I mean? Fine. For us to be able to get the factors of this particular polynomial of what? The highest degree is 3. This is what we call it a cubic expression. Cubic what? Expression, because the highest degree is 3. That means the root of this polynomial expression will be 3. Will be 3 because it has the highest degree of 3 as the what? The highest, it has 3 as the highest degree of x, the variable x. So in this case now, let's use trial and error method to know the factor of this polynomial. We start with which of these factor will be what? Factorizable. Now, let's put x is equals to 1 into this polynomial. Let's say put x equals to 1. By the time we put x equals to 1, let us see what will happen. That's why we call it trial and error method. We have 1 cubed minus 1 squared plus 4 multiplied by 1 minus 4. Good. Let's check. 1 minus 1 is 0. Good. 0 plus 4 minus 4. 4 times 1 is 4 minus 4. This is what? 0. Beautiful. Beautiful. So you see that when we put 1 into this particular expression, we get what? X. When we put x to be 1, we get the polynomial becomes what? 0. So x is equals to 1 is a factor. X is equals to 1 is a factor. Now, because when we put 1 into this expression, we have 0. So in this case now, you bring 1 here, you have x minus 1 is now what? A factor divisor. We call it a factor divisor. Because when we put x equals to 1 there, the polynomial expression gives us 0. So by the time we now transfer this one here, it becomes what? X minus 1 equals to 0, But basically, what we need is this particular expression. X minus 1 is equals to 0. Putting it there, you get what? The entire factor to what? 0. Now, that means we can use x minus 1 to divide this expression. Yes, if we divide this polynomial expression by x minus 1, there will not be what? There will not be a remainder. That's what it means. So let's check. Let's check. Don't forget, we are asked to factorize. So let's now use x minus 1 as what? As our divisor. Let us use x minus 1 what? As our divisor. So we have x minus 1, good. The expression itself is what? S cubed minus x squared plus 4x minus 4. Beautiful. Now, how do we divide? Beautiful. Now, let's pick the highest degree of x is coming from what? Is this is the first term that has the highest degree of x. So we pick x cubed all over. The first, degree of x here is x. So, over x. Okay? So, always target x. The highest degree of x we considered from our what? Polynomial. And the highest degree of x we considered from our what? Factor divisor. So now, yes, divide s cubed by x, you have what? This one what? S cancel s cubed with what? S squared. Good. I hope you understand. Good. Now we have x squared here. Okay, because this one is s in 3 places. If you cancel one out, it will mean x squared. Beautiful. Now multiply x squared by x minus 1. How do we go about that? Fine. X squared multiplied by what? X minus 1. Let's try to that could be done. How that could be done? X squared times x is what? X cubed. Beautiful. X squared times minus 1, that's minus x squared. Fine. So let's write it here. X cubed minus what? X squared. Okay? Now, you now subtract. Normal, our traditional way of doing division. Now subtract the whole of this expression from this. You put minus 1 here. By the time you put minus subtract this particular expression from the one up, from plus. Okay, so x cubed minus s cubed cancelled, minus s squared plus s squared cancelled. Beautiful. What do you have left here now? You have what? Plus 4x minus 4. Good. Now pick this plus 4x now. Plus 4x also divided by the x here. Good. So by the time you divide that, you have what? X cancelling x, you have plus what? Plus 4. So it remains what? Plus 4 here. Good. It remains plus 4 there. Now multiply plus 4 by x minus 1, just like you did in the first case. Now plus 4 times, let's do it like this. 4 times x minus 1. Okay? 4 times x is what? 4x. Good. 4 times minus 1 is minus 4. Fine. You can see that what you have up is what you have down. So in this case now, if you this, everything will be 0. Let's try. By the time you say subtract the one from now, the one below from the one up, minus here, this one will change to plus. So plus 4x minus 4 is cancelled. Minus 4 plus 4 cancelled. So what do you have here now? You have 0. Okay. So in that case now, what do? You don't have a remainder. Why don't we have a remainder? We don't have a remainder because x minus 1 that is used as a divisor is a factor. So anytime you divide, a polynomial expression by its factor, you will not have a remainder. So in that case now, they can also say what? S cubed, therefore, s cubed minus x squared plus 4x minus 4 is now equals to what? The answer we obtained up here is now called quotient. Okay? So now we've got x minus 1 multiplied by what? X squared plus 4. So this is what? This is the factorization or the result where you factorize this expression. So you can't solve this one further. If you want to do this one further, breaking it more and more, you will actually have a lot of difficulty. Because finding the value of x here, might lead you to trouble. For you to get the result of 0 here, that will be difficult. That will be difficult because if you use x with minus 2 squared is plus 4. If you use x to be 2, it is still 4. It is still 4. 4 plus 4 is not 0. So we stop here because we can no longer further solve or break x squared plus 4 into a simpler version. So the result of that now is what? X minus 1 into x squared plus 4. That's the factorized version, the result, the expression that we obtain from the expression, from the polynomial itself. So that is that about that. That's that about that. So in this case now, the factor of this, this polynomial expression is x minus 1. Why do I call it a factor? Don't forget, I call it a factor because it's when x minus 1 is used to divide the polynomial expression x cubed minus x squared plus 4x minus 4, we don't have a remainder. We don't have what? We don't have a remainder. So x minus 1 is a factor of that expression. Okay? I hope that is understood. Yes, let's go to the next question quickly. Let's go to the next question quickly. We have a lot to do today. Let's go to the next question quickly. Now, the next question, we haven't done that. We have been able to understand what we mean by what? Factor of a polynomial. Now, let's talk about something like addition and subtraction of coefficient of two polynomials. Suppose let's say f1 of x, let's say it equals to what? 2x cubed minus 6x squared plus 4x. And let f2 of x be minus 7x cubed plus 3x minus 9. These are what? They are what? They are two polynomials. They are what? They are two polynomials. The first one is a cubic polynomial. The second one is equally what? A cubic polynomial. Now, suppose the question asks us, or we are asked to find the sum. Therefore, the sum of f1 of x plus f2 of x, that is sum of f1 of, that is the sum of the two now will be, that is, say what, 2x cubed minus 6x squared plus 4x, good, plus, okay, minus 7x cubed plus 3x minus 9, good. Now, let's add them together. We collect like terms, collect like terms. So now we have what? The like terms, we have plus 2x cubed minus 7x cubed. 2s cubed minus 7s cubed, yes, minus 6s squared, yes. Unfortunately, the second polynomial does not contain s squared, so we move on. Then we don't have anything to add to 6s squared. Then plus 4x plus 3x, because we have x, we have x on the two polynomials. So then this one does not contain a constant, so we have minus 9. So that's it. We are adding directly addition of two polynomials. So here we have what? 2s cubed minus, you can say that these are like terms because both of them contains s cubed. So when you add them together, it's like saying 2a minus 7a. That's minus 5s cubed. Okay, then minus 6x squared. Okay, now plus 4x plus 3x, that is plus 7x. Okay, then minus 9. So this is the result of the addition of the two polynomials. Now suppose we are asked to find then what is the coefficient? What is the coefficient? What is the coefficient of s cubed in f1 of x plus f2 of x? That is, what is the coefficient of s cubed in that summation? Now, obviously, we have added the two together and we have gotten a result. Now, the coefficient of s cubed here is just go to that particular result that you have obtained. What is the real number there? The real number that is multiplying s cubed. The real number multiplying s cubed here is minus 5. So the coefficient of s cubed is minus 5. Beautiful. That's it. Now, suppose the question is, what is the coefficient of s squared? You go to s squared. This is s squared. The real number multiplying s squared is minus 6. If it were, what's the coefficient of x? The real number multiplying x is plus 7. So that is how to find the coefficient in given what? In given polynomials. So that is that about that. That's that about that. Let's move on. 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 Okay. Now, the next area I want to touch here is finding the values of numbers. For example, which is equivalent to substitution, direct substitution. Suppose we are given f of x is equal to 2x squared minus x plus 1. And the question now says find f of minus 3. Find f of minus 3. This is very simple. If f of x is equal to this, what is f of minus 3? What the question is just saying simply is when x is equal to minus 3, what is the value of f of x? This is the polynomial you are given. So you are now asked to find when x is equal to minus 3. Just substituting 2 into minus 3 squared, beautiful. Then minus 3, yes, plus 1, good. Okay, now that becomes what? 2 into minus 3 squared means what? Minus 3 times minus 3. Then minus times minus there means what? Plus 3, then plus 1. Okay, so that gives us what? That gives us what? 2 into bracket. Minus times minus is plus. 3 times 3 is 9, good. Then plus 3 plus 1 plus 4. And that gives us what? 18 plus 4. So the result is what? 22. So f of minus 3 is equals to what? Is equals to 22. Oh, beautiful. Beautiful. Now suppose the question now says, find f of x squared minus 1. Okay? Now what you just need to do is, what is the value of f of x when the result is x, when our x is x squared minus 1? So what do we do? Just put it there now. Therefore, f of x now will be 2 into, now the question is, whenever you see x now, you put x squared minus 1. That's the meaning. So this is x squared minus 1, everything all squared, fine. I hope you understand. Beautiful. Minus x squared minus 1, then plus 1. Okay, so you have what? 2 into, now, what is the square of this? There was a time I taught you a method on how to find the square of something like this. This is what? Difference of two squares. If you want to find the square of this, let's check. Multiply this by this now. That is what? You have x squared. Pick x squared now. Good. Now multiply x squared minus, multiply by minus 1. That's minus x squared multiplied by 2 minus 2x squared. Sorry, this will be x raised to power 4. Sorry. That is the square of x squared is the x raised to power 4. Then x squared times minus 1 times 2. Ow. That 2 is a constant. You multiply x squared by minus 1. That is minus x squared multiplied by 2. Minus 2x squared. Then minus 1 squared. That will be plus 1. Okay. Then when you open up this bracket, you have minus x squared plus 1. Then plus 1. Let's check what I've just done here, whether it is correct or not. X squared minus 1, x squared minus 1. Let's check. X squared times x squared, that is x raised to power 4. I hope you understand, according to the law of indices, x squared times x squared will be x raised to power 4, fine. X squared times minus x times minus 1, minus x squared, good. Minus 1 times x, minus 1 times minus 1, plus 1. All right, so that gives us what? X raised to power 4 minus 2x squared plus 1. So we are correct. How did I do mine? How did I do mine? Rather, that's a slip of tongue. How did I do mine? Fine. Now, what I did is just let me show you the trick. Suppose you have to find x minus 3, let's say x minus 5. I want to use let me use something else. Plus 6 squared. Yes. Yeah, I don't want to use the easier one. Now, want to find the square of this. What you just need to do is the square of x is x squared. Okay. Now multiply this x by this plus 6. That's 6x. Then multiply by 2 plus 12x. That's all. Then plus 6 square, find 6 plus 36. So that's how to find without instead of expanding like I did here. You can quickly do that. That's the method. So in this case now x squared, the square of it is x raised to power 4. Then x squared times minus 1, that's minus x squared times 2. That's minus 2x squared. Then minus 1 squared, that will be plus 1. So that is how I did that. It's a shorter way of solving expansion problems. So let's go on now. We have what? Let's open the bracket. 2x raised to power 4. Then 2 times minus 2x squared minus 4x squared. Yes. Then 2 times plus 1 plus 2. Then minus x squared now. Plus 1 plus 1. What is that? Plus 2. Okay. So let's collect like term. 2x raised to power 4 minus 4x squared minus x squared plus 2 plus 4. That gives us 2x raised to power 4 minus 4x squared minus x squared. That's minus 5x squared. Good. Then plus what? Plus 4. So that is the result. That is the result. So that is that about that. That is that about that. Okay. Now let's move on. Let's move on because of our time. Let's move on. I hope you are enjoying this. If you are enjoying it, type yes, please. If you are enjoying it, type yes. Oh, if you are enjoying it, type yes. I want to see you typing yes. Yes, say yes. Oh, beautiful. Thank you. Thank you. Kenny. Thank you, Ola, Daniel. Ayomide. God bless you all. God bless you all. Now, let's look at the remainder theorem proper. The remainder theorem proper. The remainder theorem. The remainder theorem. Okay, let's look at it holistically here. Now, suppose we are asked to divide or find the remainder. Let me fabricate this. Find the remainder. Find the remainder when 3x cubed plus 6x minus 1 is divided by x minus 3. Find the remainder when what? When 3x cubed plus 6x minus 1 is divided by x minus 3. Now, we don't have to waste our time here. It's a very straightforward thing. Suppose you come across question like this in the nearest future or whenever you are asked to find the remainder. You don't need to use your long division method here. No, it will waste your time. There's a very short method, shorter one, that will quickly give you the result. Because what you're asked to do naturally here is to do what? To rule this, put this one there, 3x cubed plus 6x minus 1, and now put x minus 3 here and divide. That's it. Okay. Oh, let's try this and see if we use the shorter method whether we're going to get the same result. Now 3x cubed, you pick it up, That's the main, the one with the highest degree of x, divided by x, like we did the other time. So s cancelling this, we have 3s squared, which means 3s squared. So you write your 3s squared there. Good. Now, multiply 3s squared by x minus 3. Well, let's check that. 3s squared x minus 3. Now, let's multiply out. 3s squared times x. That's what? 3s cubed. Good. Then minus 3 times 3s squared minus 9x squared. I hope that's correct. Oh, yes. Now, subtract this from this. You put minus here. This one will change to plus because minus is plus. So, this will cancel this because 3s cubed minus 3s cubed is 0. Now, what do you have here? 6x plus 6s plus 9s squared. You cannot add them together. So, you write 9s squared first because 9s squared is more in value than 6x because of the square on x. Then you now put plus 6. You bring it down. Okay? Now, divide 9s squared by x. 9x squared all over x. Oh yeah, let's try. X cancel squared here. You have plus 9x. So you write plus 9x here. Good. Now, plus 9x multiplied by x minus 3. That's what? 9x times x. That's what? 9x squared. Good. 9x plus 9x times minus 3. Minus 27x. Beautiful. Now use what? You subtract this from this as well. Minus put here. This one becomes plus. Okay? Now you have this one cancels this. 6x plus 27x. That's what? Plus 33x. Good. Then what? You bring 1 down. Minus 1. Bring it down. You bring that minus 1 down. Okay? I hope you understand. Adding this and this together, you have 33x. Then bring minus 1 down. Now divide 33x by this x again. As usual, 33x over x. As usual. Okay? S cancelling x. You are left with 33. And it's plus. You know it's plus here. Because plus 6x plus 27 is plus 33x. So when you divide 33, you have what? Plus 3 left. Plus 33 left. Plus 33. Okay? Please, are we communicating here? Are we communicating? All right. Now multiply 33 by x minus 3. 33 times x. 33x. Good. That's plus because plus times plus is plus. 33 times x is 33x. Then 33 times minus 3. That's minus what? Minus 99. Yes, minus 99. Oh yeah, subtract again. Put minus there. This time we change to plus. 5. Now what do you have left? 33x minus 33x, 0. Now minus 99. That's what? 98. So using this long division method, the remainder here is what? 98. Okay. Now you can see how some minutes we have wasted a lot of minutes on this alone. So this is time wasting. Don't forget you are doing CBT, and CBT, you know, your working is not needed by the examiner. What is needed is what? Your answer, the accuracy of your answer. So let's now use the alternate method instead of using this long division method. Let me do the alternate method here. Oh, let me clean it. Don't forget the remainder was what? 98. We obtained 98 as our remainder. Now let's use the shorter method, which is very, very fast. Within 1 minute, we are done. Now, whenever the question says find the remainder when something is varied by something, don't stress yourself. It means that this x minus 3 is our divisor, and so now equate it to 0. Let x minus 3 equals to 0. So by the time you do that, what? That implies x will be equals to 0 plus 3. X equals to 3, because by the time you transfer 3 here, it becomes plus. So x equals to 3. Now put f of s equals to f of 3. Because it's been of this language, you don't need to be writing all this while you are doing your CBT. Just note that your x is 3. Yeah, that means this one means what? 3 into 3 cube plus 6 into 3 minus 1. That's what it means. Okay? So that means 3 into 3 cube is what? 3 times 3 times 3. Then plus 6 times 3 is 18 minus 1. So that's what? 3 times 3 is 9. 9 times 3 is 27. Good. Then plus 18 minus 1, 17. Beautiful. Now, what is 3 times 27? 3 times 7 is 21. 3 times 2 is 6. Plus 1. Plus 2 rather. 81. Plus 1, 7. What is what? 81 plus 17 That is 98. You can see that we obtain the same result. We obtain the what? The same result. We obtain the same result. So which one is faster? Obviously, this method is faster. This method is faster. So let's look at another one. This method is faster. So we are done with that as well. We are done with that as well. Now, this is another interesting polynomial question which was treated in our class. Let's say find A if x cubed plus ax squared minus x minus 8 is divisible by x minus 1 or so. X minus 1. Fine. Now, what are we asked here? What you have been doing so far is indirectly being asked here. So we are asked to find the value of this A if this polynomial is divisible by this. The simple truth there, without wasting your time, is you are being asked to find the remainder as well. Invariably, you will see. You will say, okay, you will see now. Our divisor is x minus 1. So you now say, put f of x into f of x minus 1. Okay, let me sort them out first. Let me sort this out. Let x minus 1 is equal to 0. Okay, that implies what? X is equal to 0 plus 1, because by the time minus 1 comes, it becomes plus. So x equals to 1. So you now say put f of x equals to f of 1. That is, our x is 1. Now that implies 1 cube, good, plus a into 1 squared, good, minus 1 minus 8. It must be equal to 0, because since we have been told that it is divisible, it means it does not have a remainder. You remember the very first question we started with today? I told you that an expression is a factor if whenever you put the value of that constant in polynomial, the result will be 0. So in this case now, this x minus 1 will be a factor because it is divisible, because the whole polynomial is divisible. When you hear the word divisible, that means you are not expecting any remainder. So in this case now, we are going to equate this to 0 by the time we put x equals to 1 there. Okay, let's check that. So 1 cube is 1 plus a, because a times 1 square is 1. 1 times a is a. The minus 1 minus 8, that's minus 9, is equals to 0. So collect like terms, a will be equals to what? 0 minus 1 plus 9. You are taking them to the other side. So a will be equals to what? Minus 1 plus 9. And that is what? 8. So the value of a in that expression is 8. The value of a in that expression is 8. Okay? That is that about that. I hope you are following. If you are following, please say yes. Type yes. If you are following, type yes. Type yes. I hope everything is going well. If you are following, type yes. Type yes. If it's blurred in your case, if it is blurred there, it is likely your network there. The network is not the same. Your place there might be blurry in terms of network selection, but I'm very sure that it is clear here. I can see it clearly here, and everything is all right. So it could be your network, please. Now, these are the areas I want to look at as far as this tutorial review class is concerned under what? Polynomial. So the next content or the next topic we're going to talk about now is AP and GP. AP and what? And GP. Now, quickly, what's the nth term of AP? That's A plus N minus 1 bracket D. That's nth term of AP. And if the last term is given, you change this one to be L is equals to A plus N minus 1 bracket D. So now, what is the sum of n terms? Sum of n terms equals what? N all over 2 into what? 2A plus N minus 1 bracket D. If you can still remember that, click quickly. Okay. Or you can say that Sn is equals to N all over 2 into A plus L to A plus L. That is if the last term is given. So you either use this or this. You either use this or this. Okay. Now let's look at let's illustrate this with example. Suppose we are asked to find the 10th term of, let's find it for 10 term of this AP, 2, 6, 10, 14, and so on. Now, we want to find the 10th term of that. Now, most times the questions will not come straight. Most times they will not ask you to find the 10th term of AP or GP. It will not come straight. It is now up to you to know, to find out whether it is actually an AP or GP. And how do you know? Fine. If it was an AP series or AP term, you know, there will be common difference there. But if it was a GP, there will be common ratio. So the common difference is constant in AP, while common ratio is constant in GP. How do we now know whether it is an AP? First of all, in this particular given expression question, our first term is 2. The very first element given is 2. That's when n is 1. So call this one is T1. Okay? You know, I said Tn. That is when n is 1, the first position. The number that occupies the first position is 2. So when n is 2 now, that is T2 is what? 6. So to know whether it's an AP, subtract T1 from T2. That is, let it like this, T2 minus T1. Always subtract the one in front here. The one coming first from the one that follows. That's the way it is done, okay? So that was 6 minus 2. That is 4. Good. 6 minus 2 is 4. Let's check. Before we can say this is constant, we have to check the other one, the next two consecutive numbers. You know, we have gotten this T2 is 6. What is T3? T3 is what? Is 10. Is it true that 4 is the common difference? Let's check. To get the difference between 6 and 10 is what? T3 minus T2. Okay? That was 10 minus 6, which goes to 4. Fine. So it means that when you subtract this from this, it is 4. When you subtract this from this, it is 4. So if you try the other one, the last one too, if you subtract that from that, it will still be 4. So that means 4 is constant and 4 is a common difference. So obviously, this means this is an arithmetic, an AP series. It's an AP series. Okay. Now, what do we now do? The question says, find the 10th term. Find the 10th term. The 10th term. That is the number that occupies what? The 10th position. The number that what? Occupy what? The 10th position. What is that number? Fine. Let's check. Let's check. Okay. Now, our n is now what? Is 10 because it's 10th term. Nth the 10. So therefore, T10 will be A, the first term, like I told you, the first term here is 2, fine, plus N, the number of terms, that's 10, minus 1. Then the common difference now, D, you know, our D is 4. You have seen that? It's 4. So that was 2 plus 10 minus 1 is 9. 9 multiplied by 4. So that was 2 plus 9 times 4 is 36. So 2 plus 36 is what? 38. So the answer, the number that will occupy the 10th position in this AP series is 38. So that is that about that. Now, let's look at another aspect of AP. I'm going to use this particular example to find the sum of AP. All this formula must be what? Must be committed to your memory. You must know how to quote them from your reservoir of knowledge, from your medulla oblongata. Okay? Now, I want to find, suppose the question says, find the sum of the first 10 terms of 2, 6, 10, 14, and so on. Fine. Obviously, we have known that this what is an AP. It's an AP series. So we don't need to waste our time. Sum nth term is what? I told you, n all over 2 into bracket what? 2a plus n minus 1 bracket d. The other one will not be used because the last term is not given. So L is not needed here. So that implies sum of the first 10 term. 10. That's when it is 10. Okay? Sum. So n is 10. 10 all over 2. Good. Into 2 times our a. 2, you know, okay, we have written the question here. 2, good, plus our n is 10 minus 1. Then our d, you know, it's the same question we solved here. D is 4. 4, good. 10 over 2 is 5 into bracket 2 times 2 is 4 plus 10 minus 1 is 9 multiplied by 4. Good. So this is what 5 into bracket 4 plus 9 times 4 is 36. Fine. So that gives us what? 5 into bracket 4 plus 36. That is 40. Okay. 4 plus 36 is 40. So 5 times 40 now will be equal to what? 200. So the sum of the first 10 terms of that AP is 200. It's 200. So we move. Let's now go to the what? The geometry progression. Let's go to geometry progression. Let's go to geometry progression. Okay. Now let's go to what? Geometry progression. Fine. Now in geometry progression, the number of time Tn in geometry progression is what? AR raised to power n minus 1. That's GP. Nth term of GP. We are talking about GP. And what is the sum of geometry progression? Sum is what? A into R raised to power n minus 1 all over R minus 1. This is when your R is greater than 1. But if your R is less than 1, it will be what? X is equals to A into 1 minus R raised to power n all over 1 minus R whenever R is less than 1. Now, the difference, like I told you, between AP and GP is simply the constant between them. In AP, the constant is what? Common difference. But in GP, the constant is what? Ratio. It's ratio. Okay. Now, let's illustrate this with a question. Suppose we are asked to, let's start from here. Find the nth term. Find the nth term of, let's write, I don't want us to know to indicate whether it is AP or, okay. Let's say we have dot. Let's assume we have that. Good. Now, how do we know whether this is going to be what? AP or GP? Let's try with what we did for AP. You know, the first term here is A is equals to 2. The second term, T2, is equals to minus 4. The third term, T3, is equals to 8. Now, let's check. If we say T2 minus T1, that will be minus 4 minus 2. That's minus 6. Okay? If you use difference, so now T3 minus T2, let's check. That's 8 minus 4. That's 8 plus 4. Because minus is plus. That's 12. Obviously, this is not an AP. Why? Because minus 2 is not equal to 6. It's not equal to 12. Minus 2 is not equal to, minus 6 is not equal to 12. Sorry about that. Minus 6 is not equal to 12. So there's not a common difference. Since the result we obtain when we subtract T1 from T2 is minus 6, when we subtract T2 from T3 is 12, that means this is not an AP series. If it were an AP, the common difference will what? Will be equal. Yes, will be constant. So what do we now do? Fine. Use the method of GP. Our common ratio in GP, R is what? T2 over T1 is the same thing as what? T3 over T2. All right, let's check. Let's write it here. Let's check. Now, so R is equals to, what is T2? Our T2 is minus 4. The second term, minus 4 over our T1. You know, just like in AP, except that this one is ratio. So the one following will be before the one preceding it. So minus 4 over 2. That's what? If you divide minus 4 by 2, you have minus 2. Because this is plus. Plus and minus is minus. 2 in 4 is 2. Let's check T3 over T2. T3 over T2 now. T3 is 8. Over T2 is minus 4. Let's check. Minus times plus is minus. 8 divided by 4 is 2. So you can see that it's the same thing. So this means that this is a geometrical progression. This is a geometric series. Now we use, and the question says you should find what? What the question says? We're going to say we should find, let's say, sum to, suppose we are asked to find nth term, let's say 10th term. Did I write it there? Okay, let's say we are asked to find let's take the question to 12th term. Yes, 12th term. Find the 12th term. No, we didn't actually indicate the number of terms we are asked to find. So that means T12 will be a raised to power n 12 minus 1 from this formula. Yes, we want to find the 12th term. So that will be what? That will be what? Suppose we are not asked to find the 12th term, done. Okay, let's do it this way. Suppose we are asked to find the nth term. Sorry. Yes, it's correct that way too. Suppose we are asked to find the nth term. Okay, yes, it's possible. It's possible. So that means we don't know the value of n. Good. So that's what Tn is equals to A. Our A is 2. First time. R. Our common ratio is what? Is minus 2. Minus 2. Good. Then n, we don't know. Minus 1. Fine. So, I hope you understand. It is advisable you leave your answer like this. You leave your answer like that. Because this must multiply this out. You can't say you multiply this by this and no, that will be wrong. So the answer is this. Yes. But suppose, because this is why the answer is this, is because we don't know the value of n. But now suppose that the question now says find the 12th term. Oh yeah, that was T12, because our n is given now, is equal to 2 into minus 2, then 12 minus 1. So that's what? 2 into minus 2 raised to power 11. And obviously, minus 2 raised to power 11 will give you what? Will give you minus, the value will be negative anyway. Sure, you understand? Can we try it? Now 2 raised to power 6, I think is 64. It remains another what? Another 5. That is 2 raised to power 5 is 32. Okay, let's multiply 32 by 64. 8, 12, 12, 18. That's 19. 8, 4, 2, 0, 4, 8. So that's what? Minus 2, 0, 2048. So that will be what? When you expand, minus, let's multiply 6, 9, 0, 4. So the result will be what? Minus 4,096. Minus 4,096. Okay? So that will be the result if we are to find the 12th term of that progression. So now, let's use the same example. We are using the same example so that it will make it easier for us to know the difference, the basic difference between the nth term and the what? The sum of GP. Okay? Now, we want to use the same example now. Let me rewrite the question. Find the sum. Find the sum. Let's say find the sum of the first 8th term. Find the sum of the first 8th term. Find the sum of the, I hope you can see. Can you see clearly? All right. Find the sum of the first 8th term of 2 minus 4, 8 minus 16, 32, and let's say, and so on. Good. So now, first of all, to solve this, what is our R? We obtain R to minus 2. Good. Since our R is minus 2, and minus 2 is less than 1, that is, R is less than 1. So we are going to use the second formula. Since our R is less than 1, we are going to use what? The second formula. And what is the second formula? Don't forget sum of 8th term. Okay? So our n is 8. Sum of the 8th term. Fine. So using what? Using Sn is equals to A into 1 minus R raised to power n all over 1 minus R. Because our R is minus 2 is not up to 1. So we use this formula. So that now implies, what is the first term? 2. 2 into 1 minus, our R is what? Our R is minus 2. Minus 2 raised to power n. N is 8. All over 1 minus R again, minus 2. Okay. So that gives us what? 2 into 1 minus Please don't multiply directly. Don't say minus times minus 2. Make sure you resolve this first. Find the value of this before you now multiply it out by this. Okay. Minus 2 raised by 8. Minus 2 raised by 6 is 64. It remains minus 2 times 2 again. That's minus 2 again. That's times 4. That'll be 256, I think. Okay. 256. Good. So, because it is power, it will plus. So, minus 256. The whole of minus raised by 6, raised by 8 is now 256. So, minus, okay. Then 1 minus times minus is plus 2. So, we have what? 2 into 1 minus 256, that's minus 255. All over. Okay. 1 plus 2, that's what? 3. Okay. Now, the next is what? The next is what? We just and divide by 3. We expand and divide by what? By 3. Okay? So that means what? We're going to have what? Sum of the first 8 terms will be what? Minus, so we multiply out. This is 10. 10 again, 11, remain 1. That's 5. Minus 5 out of 10 all over what? 3. So that would be what? I think 3 can go in the 5 minus 1, 7, and 0. I think that's correct. Yes. So the answer here, the sum of the first 8 terms of that geometric progression is minus 170. Minus 170. Okay. Now we move. I think with that, we have been able to cover what is coverable in this particular AP and what? GP. Now we move to another content, and that's going to be what? Matrix. So we have been able to accomplish 2 topics now. So let's go to matrix. Let's go to matrix. I hope we are following. If you are following, let me see you type yes. Type yes. If you are following, type yes. I hope you are following. Okay. Oh, thank you very much. Solomon Gabriel, Olaiwola Daniel, Toluwani Ojoye. God bless you. God bless you. God bless you. Solomon Gabriel, God's will, Abolade, and the rest. Thank you very much. Now, here we are going to discuss matrices. We know that this is when you have a set of values being arranged in a rectangular form to form an array. Okay. Now, I will be very, very predictive here. I mean, reflective here. I will have to use some kind of assumption. So let A be equals to 1, 2, 3, 4. Suppose that is my matrix A, and let my matrix B be equals to minus 1, 6, 5, 8. Good. Now, I want to use matrix operation here, and the operation I want to use is addition. So A plus B will simply be what? You are going to add corresponding entries. So the first entry here, that is this particular row and column. This is the first row, the first column, the first row, second column. I hope you understand that. Fine. So you pick the first element, 1 plus the first element in this, the first entry here as well, minus 1. That settles that. Go here, 2 plus, because you want to add them. 2 plus 6. Close it. 3 plus 5. You close it. 4 plus 8. You close it. That is it. So we now have what? Now 1 plus 1, that's 0. 2 plus 6, 8. 3 plus 5, 8. 4 plus 8, 12. Good. That is the result. Now suppose the question now asks us something like saying, find the transpose of A plus B. I want to combine 2 things together. The transpose of A. What's the meaning of transpose? Transpose means, simply what transpose means is, when you interchange the rows of the rows and columns of a matrix to get another one. When you interchange, there's interchanging of rows and columns. That's the meaning of transpose. If I want to transpose this matrix now, don't forget this is the first row, this is the second row. First row, second row. So I'll now make elements in the first row to go for column. So instead of having 0, 8 here, I will now bring it to this 0, 8. It's not this 8, the whole of this now, I bring it down, 0, 8. The 8, 12 here, I write it at 8, 12. Wow. Can you imagine? Sincerely speaking, this example will be useful in the later part of this particular tutorial. I'm still going to, okay, well, maybe let me use it now so that we don't waste our time. Wow, this is an interesting example. I just assumed though, I didn't copy it from any textbook. It's just an assumption, and it works perfectly well for me. To God be the glory. Now, what am I going to do here? Why am I so glad about this? Because I'm going to illustrate, I'm going to explain a concept to you in the later part of this course, but this one now has afforded me the opportunity to quickly chip that in. Now, when I originally have 0, 8, 8, 12. So when I transpose it, when that is all the elements in the row, you bring it to column. I will show you so that you not be confused. I will show you another example so that you not be confused. Now you observe that the result of my A plus B is the same thing as the result of my A plus B transpose. So that means that this A plus B is called a symmetric matrix. A symmetric matrix. Yes. What is a symmetric matrix? A symmetric matrix is a matrix, that is obtained when the transpose matrix of that matrix is equal to the original matrix. You can see that the original matrix I have is 0, 8, 8, 12. But when I transpose it, it returns to that. This is a very good example of a symmetric matrix. Okay, that is that about that. Now let's look at the other operation. This time around, I want to use subtraction. A minus B. So I want to change. I will just change it so that we don't waste our time. So I'll put minus there now. So it will be 1. Instead of plus there, minus 1. Fine. Then 2 minus 6. 3 minus 5. 4 minus 8. Fine. So what is the result? Now we have 1 minus minus. That's minus as minus is plus. That's 1 plus 1. That is 2. Then 2 minus 6. That is minus 4. Good. Then 3 minus 5. That's minus 2. Good. 4 minus 8. That is minus 4. Abi? Is that true? Let's check off. I don't want us to run into trouble. Okay. Yes. Now, suppose we are to find the transpose of A minus B. So let's check. All the elements in row 1 will become column 1. There are 2 minus, all right. 2 minus 4 is in row 1. Let it be column 1. 2 minus 4. Good. Now, the row 2 become column 2. Minus 2 minus 4. Yes. Yes. Obviously, this one is not a symmetric matrix because the transpose matrix is not equal to the original matrix. So A minus B transpose is not the same as A minus B. So that is that about that matrix operation. And I hope that is clear. I hope that is clear. I hope that is clear. Okay. Now let's say we want to find the determinant of a matrix. Suppose we want to find the determinant of a matrix. Let's say that we are given 2 matrices. Okay, let me coin another question from here. Let me coin another question from here. Let me coin another question. Let's find first. Find AB 2. Determinant of A, B. Let's check whether this is possible. Don't forget, this is 2 by 2 matrix. 2 by 2, 2 by 2. They are called square matrix. How many rows? 1, 2. column 1, 2. So it's 2 by 2 matrix. This is also what? 1, 2 for rows, 1, 2 for column, 2 by 2 matrix. So they are what? They are conformable. The two here will compose this, and you have 2 by 2. So if something else has been here that is not the same with this, you cannot multiply them out. So AB is now what? Matrix AB is what? Is the product of the two matrices A and B. So let us what? Let us try and do this multiplication. So AB will be, now look at the way I'm going to do it too. Because some students used to complain that they don't get this, and it's simple. You are multiplying A by B. So you have 1 times minus 1. You pick the first element here, multiply it by this. 1 times minus 1 plus you have not finished. Because when you multiply 1 by minus 1, you must multiply the next element on that row with the next element on this column. So 2 times 5. 2 times 5. That is that. 1 times 6. 1 times 6 plus, you pick 1. You have used 1 to multiply minus 1 and this 2 to multiply 5. You now pick 1 to multiply 6 and 2 to multiply 8. That's all. So 1 times 6 plus 2 times 8. That's it. Okay. Now the next 3 times minus 1. 3 times minus 1 plus, you pick 3 here, multiply by minus 1. Now pick 4 to multiply 5. 4 times 5. That's done. 3 times 6 diagonally plus 4 times 8. So what is the result? 1 times minus 1 is minus 1. So minus 1 plus 10. Minus 3 plus 20. 6 plus 16. 5. This 18 plus 32. Good. So what is our result now? Let's just add straight off. Oh yeah. AB now will be minus 1 plus 10. That's 9. Minus 3 plus 20. 17. 6 plus 16. 22. 18 plus 32. 40. So AB has given us a new matrix. Sorry, 18 plus 32, sorry. Don't mind me, it's 50. Sorry about that. That's a mistake. 18 plus 32 is 50, sorry. 50, 22, 9. Now, we have gotten the solution to the first problem. How do we now get the second one? Now, the second one is asking us to find what? The determinant of matrix AB. The determinant of matrix AB. Now, I think we are done with the solution. The question. We are done with the question. We can even clean this. We can clean this well as well. So we are done with the question. So therefore, determinant of AB now will be determinant of, just this is the symbol of determinant, 9, 17, 22, 50. Okay. So how do you now find that? Fine. When you multiply this way, you pick from the left to the right and from the right to the left. So when you are moving from left to right, it is plus. But when you are moving from right to left, sorry, this is right. Okay, this is my right. Okay. When you are moving from my right to the left, it is plus. When you are moving from my left to right, it is minus. You will see it now. 50 times 9. 50 times 9. Good. Now it is plus, but when you are going this way, it is minus. Minus 17 times 22. Okay, this is 450 minus 17 times 22. This is 34, 14, 3. Okay, 473. I think that is correct. So that's what? Minus 374. So 450 minus 374 is 6. This is 7. I think it's going to be what? It's going to be 76. So the determinants of matrix AB is 76. Determinant of matrix AB is 76. Okay, so that is that about that. That is that about that. I hope you are following, please. I hope you are following, please. Okay. Yeah. Okay. Yes. Now the next now is we have dealt with determinant stuff. Let us try another similar or related question. Suppose if A, matrix A is given as, suppose if A is given as, let's treat this question as well, x plus 2, 1, 4, x minus 3. Find the determinant of A, just like what we did now, but this one is algebraic. This one is an algebraic expression. So now, determinant of A will be this way. Oh yeah, x minus 3 times x plus 2, good. Then minus 4 times 1, or 1 times 4, whichever way. So that gives us what? X multiplying x plus 2, then minus 3 multiplying x plus 2, minus 4. I hope that is clear. Okay, so we have what? X squared plus 2x minus 3x minus 6 minus 4. All right, that what? X squared minus x minus 10. Okay, so that is that about that. So the determinant of A in this case is x squared minus x minus 10. You'll be wondering, but we get our expression. Yes, we can get it like that. Because it's just we have followed the pattern of that, we have followed the method of determinant. Don't forget, I have assumed that you understand that I have put this there. Okay, I have put the symbol of this there. So don't have to waste your time. You are doing what? You are doing CBT. It's a computer-based exam. You can't be writing down all stories. Let's now write this. Go straight to the point. You don't have time. So the determinants of that matrix is that. Now let's look at another related one. But this time around is going to be what? We have done something very close to that. When we are asked to find that is the scalar multiplication of determinants. The scalar multiplication of determinants. That is very easy. When you multiply determinants, it's the scalar multiplication of matrix. Let me give us an example. Let A be a matrix. Well, let me use 3 by 3 this time around so that it won't be that I'm trying to avoid 3 by 3 matrix. Now, suppose we want to find, the question now says, find 2a plus, let's say 3b. So, now 2a here, 2 is a what? It's a scalar. That will be what? 2 multiplying 3, 5, 6, 2, 0, minus 7, 1, 8, 4. Okay? And that will be what? You multiply everything by 2. So yeah, 2 times 3 is 6, 2 times 5 10, 2 times 6 12. Is that clear? Okay. Now 2 times 2 4, 2 times 0 0, 2 times minus 17, and 2 times minus 7, sorry, minus 14. 2 times 1 2, 2 times 8 16, 2 times 4. That's 3 times, what's our B? Minus 1, 5, 9, 4, 8, 2, 6, 7, 1. So that gives us what? 3 times minus 3, 3 times minus 1, minus 3. 3 times 5, 15. 3 times 9, 27. Good. 3 times 4, 12. 3 times 8, 24. 3 times 2, 6. 3 times 6, 18. 3 times 7, 21. 3 times 1, 3. So now to add them together, that's the next thing now. We want to add them together. So let's use the upper side. Let's use the upper side. Let's use the upper side of it. Therefore, 2a plus 3b will now be equals to, what did you get for your 2a? This is what we got for our 2a. This is what we got for our 3b. So let's add them. Now, 6 minus 3, 10 plus 15, 12 plus 27, oh yeah, 4 plus 12, 0 plus 24, minus 14 plus 6, 2 plus 18, 16 plus 21, 8 plus 3. I hope that is clear. Okay? If that is clear, type yes, type yes, type yes. If that is clear, type yes. Type yes on the screen, type yes on the screen. If that is clear, type yes on the screen, please. Can I see your yes? Can I see your yes? Yes. Okay. Okay. So 6 minus 3 is minus what? Oh, it's 3. Yeah, 6 is more than 3. It's 3. 6 minus 3 is 3. 10 plus 15, that's 25. 39, good. 16, 24, minus 8, yes. 20, 37, 11. So that is 2a plus 3b. 2a. I'm going to give you some exercises to do. You will do the minus yourself. Somebody was asking me, can I do the minus 1 as well? Yes, I can, but it will take our time because we still have some other things to do. So you do the minus. If you get it right, I will tell you. If you are wrong, I will correct you. Okay? Now, that is that about that. Now, we also learned something called equality of matrices. Equality of matrices. When are two matrices said to be equal? Two matrices are said to be equal if their corresponding entries are equal. How? What do I mean? Fine. Let me give you a good example. This is a matrix A. And the matrix A has A11 as entry, A12, A13. And its elements, the first row, first column, first row, second column, first row, third column. So A21, A22, A23, A1, A32, A33. So I hope these are the entries in this matrix A. Let me do it this way. So matrix B, let's say matrix B has B11, B12, B13. Good. B21, B22, B23. Fine. B31, B32, B33. Beautiful. Now, A will be equals to matrix A is equals to B if A11 is equals to B11. That's just it. A12 is equals to B12. A13 is equals to B13. So just when the corresponding entries are the same. Okay, let me help you. A11 is equals to B11. A12 is equals to A13 is equals to B. I hope you can get this clearly. I hope you can get that. Can you get that? All right. So A21 is equals to B21. A22 is equals to B22. A23 is equals to B23. I hope you get it now. A31 is equals to B3. A32 is equals to B32. A33 is equals to B33. So that is when they are equal. Now let's look at an example under it. Now, find the values of x, let's say x, y, and z if the following matrices, or let's say y and z if, let's write like this: 2x, 2, 3, 11, 16, 8y, 5, 4z, 9 is equal to, if that matrix is equal to this, 4, 11, 5, yes, 2, 16, 8, yes, 3, 24, 9. First of all, what are we asked to find? We are asked to find this, we are asked to find this, we are asked to find this. Let's check whether others are the same. 2, 2, 3, 3, 11, 11, 16, 16, 5, 5, 9, 9. Oh, that means this matrix must be equal to this matrix. So in that words, now say what? Which implies 2x is equals to 4. Because 4 is what we have here in this position. So dividing both sides by 2, x will be what? 2. So simple. 8y. What other corresponding values do we have in the other? This is y. This is occupying this. You can see this. The entry here is correspond to the entry there. So 8y is equals to 24. Dividing both sides by 8, y is equals to 3. Now, where do we see 4z correspond to this? So 4z is equals to 8. Z will be equals to, dividing both sides by 4, 8 over 4 is what? Is 2. So that means x, y, z are what? Okay, if you can't see that, let me write this one here clearly. So we have 4z is equals to 8, z is equals to 2. So that means x is 2, y is 3, and z is 2. Z is 2. Okay? For some that might say they didn't see clearly, z is 2. Z is 2. Let me write my z clearly now. Z is 2. All right, this z, not 2. So that is that about equality of matrices. I hope we are getting closer and closer to the end of the exercise. Now, another interesting thing, I think, okay, we have discussed order of matrices, we have discussed transpose of a matrix, we have discussed a symmetric matrix. Beautiful. Now let's look at using determinant method to find the values of what? Of unknowns in matrices. Using the determinant method to find the value of what? Of unknown in matrices. We learned that as well. We have used Cramer's rule. I hope you can still remember the rule of Cramer. Good. You can still remember the rules of Cramer. So if you can remember that, that will be very beautiful. So it will help us to quickly understand what we want to do now. Now, use the determinant method or Cramer's rule. Which I say determinant method, it means Cramer's rule. Okay, Cramer's rule. To find, we want to use Cramer's rule to find, the values of x and y in the following matrices. Want to find the values of x and y in the following matrices. So we have, in the following system of equation, not matrices, really, following system of equation, because it's not yet a matrix. Let's say we have 4x minus 3y is equals to 15. 2x plus 5y is equals to 1. So we want to use determinant method to what? To find the values of x and y. Now, you know, ordinarily we could have used what? We could have used simultaneous equation method. Yes. Actually, you see, the thing is this. In the test or exams, if questions like this come out, if you know that simultaneous equation method will be faster for you, you can use it. You still get the answer. But if you know that you can use Cramer's rule very well, it's still okay. Both of them are correct. It depends on how you can maneuver and manage your this thing. So the very first thing we are going to do now is let's write the matrix form. The matrix form of this equation. The matrix form, let's say, is A equals to what in a matrix form now. 4, we pick all the real numbers, 2, -3, and 5. That is the matrix form. Okay. Now, you know, actually what we are targeting is we want to express our matrix in form of AX equals to B. Okay? AX equals to B. So, the next here will be XY, because this X will now represent the unknowns that we're looking for. And the B is the values we have, the column matrix for our constant. 15 and 1. Good. That is how we are going to do it. All right. Good. Now let's now write AX. But before we write AX, let's find the determinant of A first. Good. That is, determinant of A will be 4, 2, -3, 5, which will be 5 times 4 minus 2, open the bracket, times -3. Yes, you have to close it. Minus before this 2 is used to multiply -3. So that will be what? 20 minus -6. Yes, that's 20 plus 6, which is 26. Okay, so our A is 26. Our A is 26. Now, we need to find the equivalent value, the equivalent matrix form of X. Equivalent matrix form of X. How? Don't worry. Don't worry. You will see it now. I've cleaned this thing. Okay, yes, I can see maneuver. Let me say equivalent matrix form in X. Let me use this. Let's say matrix form AX. Now, I think that will make you to remember. Now, go to the original matrix. You know, the original matrix form is our A is 4, 2, -3, 5. Now, we said X. This column is for X. Why this column is for Y? Yes. You know now. You know, we say 4X plus 5Y. I mean, 4X minus 3Y. Then 2X plus 5Y. So this column is for X, this column is for Y. So on this X column, remove it and replace it by this constant. You have 15, 1. Then you are left with what? -3 and 5. Yes. Now find the what? Find the determinant of AX. That will be what? 5 times 15 minus 1 times -3. So that gives us what? 75 minus times minus plus 3. That's 78. That's 78. Don't forget, you can write it somewhere. Our A, the result we get for A is 26. The determinant of AX is 78. You can write somewhere so that we don't make mistakes. Okay. Now, let's now do for AY. Let's do for AY, the forms of AY. The form of AY. The form of AY. Okay. AY. For AY, we'll be having what? AY will be, I've cleaned it. Oh, God. Shit. And no problem. I'll remember. So that will be what? We need only to replace Y. We have 4, 2. We know our Y was -3, 5. So it will not replace by 15 and 1. 15, 1. Yes. So we have replaced the column for Y. Originally, Y here was -3 and 5. So just like we did for AX, we do for AY. So X, the column for X will be retained, but we now change the column, we interchange the column for Y with what we had as a constant. So that means the determinant of AY will be 4, 2, 15, 1, which will be what? 1 times 4 minus 2 times 15. That gives us what? 4 minus 30. Is that clear? That's minus 26. Good. So that means that our, let me write it somewhere. The determinant of AY is what? Minus 26. Good. Good. Now, what is now the value of x, y, x and y? So x will be determinant of ax all over determinant of a. And that is what? 20. Determinant of ax was 78 over determinant of a is 26. So that is 3. Then y will be determinant of ay all over determinant of a. That what? Ay was what? 26 minus 26. Determinant of a is 26. So that's what? Minus 1. So x is equals to 3, y is equals to minus 1. So that is that about that as well. That is that about that as well. Okay? That's that about that as well. Now, I think with this we have been able to cover the aspect of matrix 2. So the last aspect is set theory. Let's look at set theory. Set theory. That's the last aspect we are going to cover today. So, set theory. Now, we have a lot of set notation that we learned. We have set algebra, set symbols, and the like. We use Venn diagram to illustrate some questions and solve them. So I will expect us to still have that in our brain. We started with the definition of set, which is a collection of well-defined objects. Then finite set. When we say a set is finite, a set is said to be finite if it has what? A listable element. That is, if you can list all these elements, it has a definite number of elements. For example, number of students in your class. If I say X, a set of 100 level students, 100 level students in MTS department. Yes, because you can get the total number of MTS 100 level students. Sorry, so you can get the total number of students in that department. Yes, you can say a set of mathematical instruments, and you can list it. Instruments. Okay, these are what? They are finite. You can list all the elements there. Okay, now, but if I say, let's say a set of natural number, natural numbers. We don't know what I say natural numbers. No, we use what? Capital N this way to represent set of natural numbers. Yes. Can we list all natural numbers? Let's try. Let's see. Natural number starts from 1, 2, 3. Oh yeah. You can never list all of them. Sometimes when we are young, we used to call it organ table. No. You can't get the last number for because it's not banded above. Doesn't have upper band. So this even set of integers does not have n too. This is it. That starts from 0, 1, 2, 3, and so on. So these are what? Infinite sets, because you cannot list all their elements. But the first two examples are what? Finite sets. They are finite. Okay. So that's the concept we also learned. Set. Now we learned a concept of union, intersection, and the like, which I don't think that is difficult for us to remember. Union is when you just bring the element together. Okay, when you bring the element together, I will show you. For us to remember and for us not to make us stupid mistakes. Let's quickly discuss the algebra of sets there. The algebra of sets. Now let's set A be a set of 0, 1, 3, 5, 6, 7, 9. And it said B equals to 1, 2, 3, 5, 7, 8. Now, you want to find the union of A, B. The union of A, B is a set that contains all the elements in A and B put together. That's all. So yeah, let's start. 0 is in A, write it. Okay. There's 1 in A, there's 1 in B. Just write only 1. Oh, yes. Don't write it twice. There's 2 here. There's 3 in both, write only 1, 3. 5 in both, write only 1, 5. 6, 7 in both, write only 1, 7. Then 8 and 9. Now there's something we call cardinality of set. There is number of elements in a set. That is represented by n of, if I say n of A union B, there's number of elements in the union of A and B. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9. That's all. It's as simple as that. Okay. Now for A intersection B. A intersection B. Let's check A intersection B. That is when you look for elements that are common to A and B. Oh yeah. 1 is common there. 3 is common to them. 5 is common to them. 7 is common to them. Good. Good. 7 is common to them. So in this case now, suppose you want to find the cardinality of A intersection B. How many? 1, 2, 3, 4. So you observe that naturally the cardinality of union of sets is more than the cardinality of intersection of sets. Okay? But look at this. Let me give us another example. Let me give us another example. Let me give us another example. Let me give another example. Suppose we have a set A is equals to 2, 4, 6, 8. A set B is equal to 1, 3, 5, 7. Now we say A, A what? Intersection B. Let's look at elements that are common to both of them. Do they have common element? No. So you say it's empty. It's an empty set. Empty set is called a null set. Now, what is number of elements in both? Is 0 because they don't have common element. They don't have common elements. They don't. Now let's look at another one. There are two ways of representing sets. We have Euler set notation and tabular form. So we can also represent set like say let A be a set such that let's say -4 less than or equals to x less than or equals to 3, and let's say B is equal to a set x such that 2 less than let's say 2 less than x less than 6. Yes, this is another way. This is what we call the set Euler notation. Now say find A union B. This is another interesting question. Find A union B. Find A union B. Okay. Now, let's find A union B. Let me write it here. Let's do it together. Let's go find the two. Find A union B and A intersection B. Good. Now, solution. Solve this. Set A, this is all the set Euler notation. In this set Euler notation, properties of the set will be what? Will be defined, will be discussed. But if it was set tabular form of representing set, just list all the elements of the set. So we can move from set Euler notation to tabular representation of set. How? It was telling us that -4 less than or equal to x is the element in that interval. And it starts from -4. Why? How? Because of the what? Inclusion of this equal to. Two inequalities are there, less and equal to. So you have to start from -4. So now say what? -4, -3, you'll be counting progressively like that. -2, -1, 0. Don't forget, you are moving to the right. 1 and 2. Why? You won't stop at 3 because doesn't contain equal to. 3 is not included in the set. Fine. Now for B, okay. Or should I even use it equal to here? So that it will be equal to here, it will be equal to there. Okay. All right. We're just trying to fabricate some very interesting questions. Now 2 less than x. That means 2 is less than x. You are not starting from 2 because 2 is less than x, so x will be 3. Yes. So x will be 3. The next number is the one you're starting from. 4, 5, and 6. Wow. And 6. 3, 4, 5, and 6. Now, what is A union B? What is A union B? All right. Result what? Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. This is A union B. That is A union B. That is A union B. Now, what about A intersection B? What about A intersection B? So A intersection B will be, what are the elements that are common? Do they even have common elements? Wow. Unfortunately, there is no common element so you can write an empty set like this, yes, or this symbol. So there's no common elements in the set. There's no common element in the set. So that is that about that set. Let's quickly look at indices and possibly some questions that lead to indices, index questions. Now, having done that, for more information on set theory, I will advise you go to the video channel. There are some questions there. Go and study them. Watch the videos. You will get the knowledge of set. Application of set using Venn diagram. They are there in the YouTube video. Okay. Now, let's quickly solve questions like this. Suppose we are asked to evaluate. This is an index question. Very index. It's an index question. Also exponential. Now, suppose we are asked to find questions like this. We have done this before, but let's quickly revise this. Now, 16 raised to minus 3 will be 4. So, how do we can break 16 in a multiple of 4 if we like. So, we can say 4 raised to power 2, good, if we like. Or we can write it in form of this. 2 in what? 2 raised to power what? To get 16, 2 raised to power 4 is 16. That's 2 times 2 times 2 times 2. Then raised power minus 3 over 4. Okay. So in indices, when you have exponents being separated by parentheses, you multiply them. So you have what? 2 raised power 4 times minus 3 over 4. You are multiplying, not subtracting 3 from 4. No. This will cancel this. This will cancel this. So you have 2 raised power minus 3. So this is correct, but in most cases, the answer might be what? Expanded more than this. So this minus means what? 1 all over. Then the 2 to the power of 3. So that is what? 1 over. 2 raised to power 3 means what? 2 times 2 times 2. That is 8. So the answer to this is 1 over 8. Now let's solve this. Let's solve this. This is another exponential indicial equation. Find the value of x if 2 raised to power 2x minus 6 raised to power 2x. I think you have this 2x plus 8 is equals to 0. Suppose you want to find the value of x in this it is what? It's an indicial exponential algebraic equation. Indicial exponential algebraic what? Equation. So how do we solve this? How do we solve this? Now looking at this question, let's start with here. Now, if you look at this question holistically, you will see that something is common in the equation. And what is that? Raised power x is common. So we can change this as what? Remember, in indices, we have a raised power x raised power b. In indices, if you have something like this, you can write it as a raised power b raised to the power of x. You can interchange the position of the exponent. So in this case now, we can rewrite this as 2 raised power, let's write solution. 2 raised power x raised power 2. We can interchange them, yes, because x times 2 is 2x. Okay? Minus 6 into 2 raised power x plus 8 is equals to 0. Why did we do this? Because we have something that has 2 raised power x. So I have to be able to factor out 2 raised power x. So 2 raised power x is now common. So we can now say then, let something represent that 2 raised power x. Let's use a. So you now put a here and have a squared, because the whole of this is now a, minus 6a plus 8 is equal to 0. So clearly, we are now having what? A quadratic equation. So we can factorize fast. Multiply this by this, you have 8a squared. Finding the product of 8, that will give you minus 6a. You are going to have minus 4a minus 2a. Yes, minus 4a minus 2a. If you multiply minus 4a by minus 2a, it will give you plus 8 squared. And if you add them together, it will give you minus 6a. Beautiful. So we have a squared minus 4a minus 2a, yes, plus 8 is equal to 0. Good. So now you can bring these two, you can pair them like this. Yes, you can do it like that. So what is common there? A into a minus what is left here? 4. Then minus what is common to this? 2 into a. Then dividing 8 by minus 2, you have minus 4 is equal to 0. Yes. So bringing them together, you have what? The one inside the bracket and the one outside. A minus 2, good, into a minus 4 equals to 0. Beautiful. So equate each of them to 0. A minus 2 is equals to 0, gives a equals to 2. Fine. The other one, a minus 4 is equals to 0. The one we got, a is equals to 4. Good. Don't forget, the question asks us to find x, not a. It is x that we are asked to find. But remember, because a is not in the equation, so now return our a to 4. A is equals to 2. Then 2 will equals to 2 raised power x, because our a is 2 or 4. So now put substitution now. So, and this 2 is having how many powers? 2, 1. 2 raised power 1 equals to 2 raised power x. So the base here will cancel the base here. So 1 is equals to x, which implies x is equals to 1. Similarly, for a is equals to 4, then 4 will be equals to 2 raised power x. So we can express 4 in multiples of 2. That will give us what? 2 raised power 2, which stands for 4, equals to 2 raised power x. So this 2 here will cancel the 2 here. 2 will be equals to x, which implies x equals to 2. Therefore, x equals to 1 or x equals to 2. So that is that about that. So I think this is the most convenient point for me to stop this review this evening. I think we've been able to do enough for now. There are other related reviews that have been produced as videos for you, so you can watch all of them in the YouTube video. So I hope you enjoyed and you had a very, very pleasant tutorial this evening. So I hope, sincerely yours, which I believe, that if you go through all these exercises, all these questions, and you are able to also watch the videos that have been produced on topics you have been taught in class, you will definitely pass your coming test, even your examination. So I think I want to rest my case here. See you until next Sunday, when we shall have a new episode of Dr. OJ Digitalz Online. Thank you. God bless you. Bye.